Advances in neuroscience and engineering have generated great hope for Luke Skywalker-like prosthetics, robotic devices that are almost indistinguishable from a human limb. Key to solving this challenge is designing devices that not only can be operated with a user's own neural activity, but can also accurately and precisely receive and relay sensory information to the user. A new study by neuroscientists at the University of Chicago and Chalmers University of Technology, published on December 22 in the journal Cell Reports, highlights just how difficult this may prove to be. In a cohort of 3 subjects whose amputated limbs had been replaced with neuromusculoskeletal prosthetic limbs, the investigators found that even after a full year of using the devices, the participants' subjective sensation never shifted to match the location of the touch senses on their prosth. The stability of the touch sensations highlights the limits in the ability of the nervous system to adapt to different sensory input. 3 participants with above-elbow amputations were equipped with high-tech neuroprosthetic devices that were affixed directly to their humerus bone. The users could control the prosthetic device thanks to signals received from electrodes implanted in the residual arm muscles, and received sensory feedback via another set of implanted electrodes. A sensor located on the prosthetic thumb triggered stimulation of the nerve, which in turn elicited a touch sensation. However, because the organization of the nerve is essentially arbitrary, surgeons can't be sure whether their placement of the electrodes will generate a sensation in the correct location on the thumb. In the study, the prosthetic users did not report feeling the sensation on the thumb, but rather in other hand locations. Participants then wore the prosthesis for upwards of 12 hours a day, every day, using it to manipulate objects during their daily routine for over a year. One problem with current neural electrodes is that you can't tell during the implantation surgery which part of the nerve corresponds to what sensation, so the electrodes don't always land in exactly the location in the nerve that would match the location of the senses in the prosthetic hand, psi. Despite being able to observe their hand while interacting with objects, none of the users ever reported that they felt the sensation on their thumb, but rather that the sensation persisted in the same area where it was originally felt. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.